Welcome to the walkthrough to how to use the deploy simulator without any setup through the web interface. So the simulator and the web interface has already been deployed in a public domain, so you can just directly access it through typing in this link in your browser. And it will take you to the home page. The home page gives you a walkthrough of all the functionalities, which will start with the upload page, where you can upload a case that you define and run it for visualization or run it for getting back results um, after simulation. So we will go to this upload page, and it will show you like two access points. The first one is that the first option is to upload a case for visualization on this visualizer. The second is to upload a case for simulation results. Both of this case, you can just simply have your configuration in it and then upload it, and the simulation and the results will be generated in the backend. So we'll show you how to do the second one first. So in your blockchain simulators source code file, there are a couple of pre-configured cases that we have already defined that you can directly run. So I'll go to there. So you can go to the src config, and these are a list of folders. Each of them represent a case that we have already defined for you. So you don't need further configuration and just can directly run. So for example, I can do this one. In order to run it through this interface, I'll need to compile this folder into a zip file. So it generates a zip file. The zip file's name has to be the same as the case name. And as you can see, if I click and open this zip file, it contains the folder as the same name of the zip file. And in this folder, it has the config that we want to run. So in order to run it, you choose Browse, and you go to the folder that has the zip file and choose that and hit open and upload the case. And after it run, it will give you back the running results in a zip folder as well. So I'll just choose save, and if you open it, it will show you the message trace, the player state trace, and the output. In this case, it has an output because this is a Dolab strong case. You can see the trace of the running results. So similarly, you can also upload a case for visualization. In this case, it will be the same. So we can just choose browse and browse the same zip file and hit upload. So it will upload the case and store it in the backend for you to visualize. Um, in order to visualize the case, in this case that is a Dolab strong case, you will click this Dolab strong tab here, and it will take you to the Dolab strong case visualization page. So you can choose on the right hand side the case that you have just uploaded, and it will show you that there are 3 players, each of them currently being the floor bit because like they have just been initialized, um, and the gray one represents that the players current at the end of the current round will be the players will output the floor bit, and the purple one will mean that at the end of the current round, the player will output the zeros bit, and green for outputting 1. On the right hand side, it also shows the current state of each player, the extracted sets in our case. So player 0 is honest, player 1 is honest, and they all initialize with empty extracted sets. As you progress, right here, as you can see, since the corrupt player is the initial sender and sends 2 different bits to the 2 honest players, each of them ended up in different bits, so they have different outputs. And that is a visualization for the Dolab strong. You can also see what are the messages being generated in each round by clicking on this message button and select the case that you want to visualize, and it will take you to the um, the messages where it is being generated each round. So here in the zeros round, if we click 0, it will be the messages from player 2 to player 2, the 0th bit, but player 2 send player 0 the 0th bit, and player 2 send player 1 the 1th bit. So that's resulting in the different output of the two honest player. Even though the two honest players try to send each other the bit that they receive, since our simulation doesn't have the next round for them to receive each other's message, they ended up in different outputs. And that's how you visualize the Dolac strong case. To visualize the Streamlit case, you can click the Streamlit chain button tab here. Select currently, because it's selecting a Dolac strong case, so it says no player stays for Streamlit to display. But if you switch to a Streamlit case that you upload, for example right here, it will switch you to the Streamlit case. And currently it shows the state of all the players. So you can see here player 0, player 1, player 2. In this case, each of the circle represents a block on each player. So since we are in the init block, everyone has a genesis block, and the genesis block is in purple because purple represents notarized, gray for finalized, and green for not notarized blocks. And in our implementation, the block ID is the same as the epoch number. So, and each epoch, if you select that the config being partially synchronous, each epoch contains 2 rounds. So if you advance here, the 0th round doesn't do anything because it just sends the block proposal. But in the first round, everyone receives the block proposal, so they will add the block proposal into their chain with not notarized. And player round 2 will be and vote for that. Round 2 everyone will receive the vote from they send from round 1, so some of them being notarized right here, and we can click each round that advanced through right here. And similarly, like this is showing all the players, and you can unselect this showing all or select a specific player to view the specific state of each player. And that is also an option that's convenient to visualize a single player. So to see what are the messages generated for the Streamlit case, you also click this message button and select the Streamlit case that you want to select. And in each round, you can see that in our case, 0th round contains a proposal, round 2 contains the implicit message echoing, round 3 has this implicit message echoes plus this votes, and there are votes that are not delayed, and there are votes that will be delayed here. Delay of -1 means that it's going to be delayed infinitely by the adversary, and you can just see like all the votes right here as well. So that's how you visualize all the messages being generated in each round. And with that, that concludes the walkthrough of the visualizer.